Good evening, everyone. I'm Dr. Namita Saraswat, Associate Professor in Anesthesia from Atal Bihari Vajpayee Institute of Medical Sciences and Dr. RML Hospital. Today, I'm going to talk about a very important topic, though it is confusing, that is vaporizers. However, I'll try to make it simple and interesting. So let's begin our journey to vaporizers. By the end of the lecture, you will be able to understand what is vaporizer, what is the basic physics related to vaporizer and clinical relevance, what is the classification of vaporizer, what are historical and modern vaporizers, about filling systems and safety measures. Now, what is vaporizer? It is an equipment or device that convert a liquid anesthetic agent into its vapor for safe and controlled delivery of inhalational agents to the patient. Now you can see here this picture says that all my stress goes out with the vapor of my hot tea. And I suppose all of your stress will go out once you will be able to understand these terminologies and the clinical relevance behind them. Before moving on to saturated vapor pressure, let's learn what is vapor. Vapor is a gaseous state of substance below its critical temperature. And you can see here, there's a liquid in a closed container. The molecules at the surface with high energy will escape from the surface and bombard on the wall of the container to exert a pressure known as vapor pressure. And once this pressure attains once the molecules attain thermodynamic equilibrium, then the pressure exerted is known as saturated vapor pressure. So it is important to understand that the saturated vapor pressure varies as a function of temperature and it is not dependent on ambient pressure. The clinical relevance is that saturated vapor pressure increases as the temperature increases and vice versa. And you might know that saturated vapor pressure of inhalational agents are mentioned and measured at 20 degrees centigrade. And one more important thing related to saturated vapor pressure is later you will learn what are variable bypass vaporizer and what is splitting ratio. The splitting ratio depends on only two things, the dial setting and saturated vapor pressure. Now, what is boiling point? The temperature at which vapor pressure is equal to atmospheric pressure is known as boiling point. The relevance is that the boiling point will decrease with decrease in atmospheric pressure. What does it mean? If the water boils at sea level at 100 degrees centigrade and you are going to boil the same water at higher altitude, then it will boil at lower temperature, suppose around 80 degrees centigrade. And those anesthetic agents with lower boiling points are therefore will be more affected by the variation in the barometric pressures. What is latent heat of vaporization? The amount of heat energy which is required to convert 1 unit of liquid into its gaseous state. And mind it that the temperature remains constant as liquid turns to the gas. The clinical relevance is that the agent with less latent heat of vaporization are more volatile. Thus, what will happen? They'll vaporize faster and cool faster. Why will they cool faster? Because the heat is extracted nowhere other than the liquid itself. Then it will ultimately lead to retardation of the vaporization process. That is why the need arises of thermocompensation inside the vaporizer vessel. It could be in the form of bimetallic strip, metal rod, or external heating. This only will help to maintain the constant vaporizer output. Now, what is specific heat? Number of calories required to raise the temperature of 1 gram of a substance by 1 degree centigrade. The clinical relevance is the vaporizer construction material should have high specific heat so that they act as a heat sink and provide thermostabilization. That is why copper and water are used as a reservoir of heat. Now, what is thermal conductivity? It is a measure of speed with which heat flows through a substance. The higher the value, the better the substance conducts the heat. The relevance is that the body of vaporizer should be made up of good conducting material so that it can conduct heat energy from the environment to the agent and provide thermostabilization. That is why the vaporizers are usually made up of either copper, brass, aluminum, or steel. Now, concentration of gas can be expressed either as partial pressure or volume percentage. These are very important terms to understand. What is partial pressure? The part of total pressure due to any one gas in the mixture is known as partial pressure. So P total will come out to be the addition of the individual gas P1, P2, P3, which is also known as Dalton law of partial pressure. It depends only on the temperature of the agent. The clinical relevance is like you have to measure partial pressure of oxygen at sea level, where the atmospheric pressure is 760 millimeter of mercury. At higher altitude, atmospheric pressure will decrease. Let's take 500 millimeter of mercury. And we all know that the volume percentage of oxygen in air is 21%. So the partial pressure will come out to be 159.6 millimeter of mercury at sea level, and it will be 105 millimeter of mercury at higher altitude, where the atmospheric pressure has been taken as 500 millimeter of mercury. So that is why we feel hypoxic at the higher altitude. Why it is important here? It is important because one should know that the potency of the anesthetic agent, it depends upon the partial pressure and not on the volume percentage. Now, what is volume percentage? Volume percentage is a volume of vapor per 100 ml of the total volume of gas. That is 1 ml per 100 ml. Like if you have to calculate volume percentage, for example, let's take desflurane. It has saturated vapor pressure of 669 and atmospheric pressure here will be 760 millimeter of mercury into 100. It will approximately come around 88%. Just imagine if you will deliver this amount of desflurane to the patient, it will be fatal because MAC is only 6. That is why there is need of vaporizer which can provide safe and controlled delivery of the anesthetic agent. And the most important point here is to understand that the volume percentage is a relative value. However, the partial pressure is an absolute value. Why it is important to understand? Because it will help us to understand the estimation of vaporizer output occurring at the hypobaric and hyperbaric condition. And this we have already discussed that anesthetic potency depends on the partial pressure, not on the volume percentage. Now coming to classification of vaporizer. We'll classify the vaporizer in the form that we are able to understand the vaporizer better. Method of regulating output concentration. On this basis, vaporizer can be concentration calibrated, variable bypass, or measured flow type of vaporizer. On the basis of method of vaporization, they could be flow over, bubble through, or both, or injection type of vaporizer. On the basis of thermocompensation, a vaporizer can have automatic thermocompensation or due to supplied heat or even electronic thermocompensation, or there may be even no thermocompensation. On the basis of specificity, vaporizer can be classified as agent specific or non-specific or multiple agents that can be used inside the vaporizer. On the basis of resistance, vaporizer can be divided as plenum vaporizer, which offer high resistance to the gas flow, or drawer or inhalers, which offers low resistance to the gas flow. According to the location, vaporizers can be classified those which can be used within the circuit or those which are used outside the circuits. The vaporizer with low resistance can be used within the circuits. However, those who have high resistance are used outside the circuit. Now, why it is important? These 6 points which I have told you, in case you are provided a vaporizer in the exam, on the basis of 6 points, you can tell about the vaporizer, and then further you can start the detailing of the vaporizer. Like if you have been given a vaporizer, first you tell what is the method of regulating output concentration, what is the method of vaporization, what is the temperature compensation used, and whether the vaporizer is agent specific or not, whether it has plenum type or drawer type of vaporizer, or it can be used within the circuit or outside the circuit. So at the outset, you will be able to tell about a vaporizer. Now let's move and understand the concept one by one on the basis of method of regulating output concentration. You can see that there's a dial, or even there could be a knob on the vaporizer. You can see the calibrations and it is marked in volume percentage. So the concentration calibrated vaporizer, the vaporizer output is controlled by a single knob or a dial, and they, they are calibrated in volume percentage. These vaporizers, since they offer high resistance to the gas flow and plenum type of vaporizer usually, so they are placed between flow meter and common gas outlet, that is outside the circuit. Now coming to the concept of variable bypass. What is variable bypass? You see this is a vaporizer, this is a bypass chamber, and this is a vaporizing chamber. The purple dots you can see, these are, sorry, blue dots, these are the fresh gas flow. And these pink dots or purple dots are the vapor molecules. What happens when the fresh gas flow gets inside the vaporizer? It gets divided into two parts. Majority of the part passes through the bypass chamber, and rest of the part passes through the vaporizing chamber, and it gets saturated with the vapor molecule, come to the outlet and mix with the fresh gas flow, and it leaves the vaporizer. How much gas will pass to the vaporizing chamber and how much gas will pass to the bypass chamber, it depends on the splitting ratio. As we talked earlier, that splitting ratio depends on the control dial setting and the saturated vapor pressure of the inhalational agent. So this is the concept of variable bypass vaporizer. Now what is measured flow vaporizer? You can see there are two regulators here. Normally what happens when you switch on the fresh gas flow, it enters inside the bypass chamber. Here also it is entering inside the bypass chamber, and this is the common gas outlet. But however, you can see there is one more channel through which fresh gas flow, a measured fresh gas flow is entering inside this channel and entering the vaporizing chamber, getting saturated, coming out of the vaporizing chamber and then mixing here at the common gas outlet. So a separate stream of measured fresh gas flow is led to the vaporizing chamber. It will deliver an accurate agent concentration. The vaporizer must measure and adjust for the fresh gas flow rate. The most common example of such vaporizer are Omeda Tech 6 vaporizer, which is used for desflurane, and copper kettle vaporizer. I hope these both measured flow, variable bypass, and concentrated calibrated are clear to you. Now moving on to method of vaporization. According to the method of vaporization, first we'll discuss about flow over. It's a almost similar diagram. Fresh gas flow is coming. The blue part is going through the bypass chamber, and then a stream is coming inside the vaporizing chamber. It is getting saturated with the molecules and reaching the outlet, mixing with the fresh gas flow and leave the outlet. So what happened? Basically, it is just flowing over the liquid, getting saturated and leaving the outlet. And this vaporization can be enhanced by increasing the gas and liquid surface. How it can be done? It can be done by a wick system, spiral tracks, or baffles. Now, what is bubble through type of vaporization? What happens if fresh gas flow enter inside the vaporizing chamber and it doesn't flow over, it enter inside the volatile liquid also, break into bubbles, then get saturated with the vapor molecules and leave the common gas outlet. It is done in attempt to fully saturate the gas, leaving the vaporizing chamber. For example, you will see the boils bottle later on. Once the plunger of the boils bottle is fully dropped down, the flow over type of vaporization get converted into bubble through type of vaporization. Now coming to injection type. What is injection type? What happened? You can see this is a control dial, this is a throttle valve, this is the bypass chamber, and this is the vaporizing chamber. fresh gas flow enter inside, and if you will turn the dial to maximum or increase the dial setting, the pressure here will increase at the throttle valve. So the pressure which is exerted by the throttle valve on the fresh gas flow will be exerted inside the vaporizing chamber, and it will allow the volatile liquid to be directly injected through the nozzle in an atomized form inside the bypass chamber, and it will get mixed with the fresh gas flow and will be delivered to the patient. These are the injectors type of the vaporizer, when the volatile liquid agent or anesthetic agent is directly injected inside the bypass chamber. So understand one concept, since there is no role of latent heat of vaporization over here, so thermal compensation is not necessary in such vaporizer. Now moving on to temperature compensation. Temperature compensation can be provided by automatic temperature compensation, like alteration in the splitting ratio, which can be by bimetallic strip as in tech vaporizer, or metal rods which are used in Traeger vapor, or even ether filled bellows are used, which are mainly used in Panlon vaporizer or EMO. Temperature compensation can also be provided by computer control mechanism, like electronic vaporizer used in Aladdin cassette. It can be by the supplied heat as in Tech 6 vaporizer, which is externally heated. And there could be no compensation as in Boyles and Goldman vaporizer. Now moving to agent specific. Vaporizer can be agent specific, that only one agent can be used in a vaporizer. These are the Tech vaporizer, Traeger vaporizer, Penlon vaporizer. These are all agent specific. All the modern vaporizer further are agent specific. And here multiple agents can be used. This is ether bottle or Goldman vaporizer. So they are agent non-specific. Now coming to resistance and VOC, VIC. Plenum type of vaporizer. What are these vaporizer? That these vaporizer offers high resistance to the gas flow. Therefore, positive pressure is applied to the inlet of the vaporizer in the form of compressed gas, so that it can carry the vapor molecules to the outlet. The examples are Boyle's bottle, copper kettle, tag, Traeger vaporizers. And coming to drawer vaporizer or inhalers. These vaporizer offer low resistance to the gas flow, and a negative pressure is applied to the outlet of the vaporizer. How it is applied? When the patient breathes or inspire, a negative pressure will be generated at the outlet, which will draw the vaporizing molecule along with the carrier gas. The example are EMO, Goldman, and Oxford miniature vaporizer. Those vaporizers who are drawer and inhalers can be used within the circuits. However, the high resistance vaporizer, plenum type of vaporizer, cannot be used as vaporizer as VIC. They can be used only outside the circuit. Now these are the two important back pressure effect: pumping effect and pressurizing effect. Pumping effect is also known as hill and low effect, and pressurizing effect is known as Cole effect. Now, what is pumping effect? Basically, what happens in pumping effect, higher concentration than that is indicated on the dial is delivered. What are the situation in which it will happen? When there are high and frequent pressure fluctuations, there is less agent in the vaporizing chamber, there is low dial setting or low flow rate. Now see what actually happens. You can see a diagram. A fresh gas flow is coming, and here a back pressure is applied in the form of intermittent positive pressure or oxygen flush. So the gas will get compressed both inside the bypass chamber as well in the vaporizing chamber. What will happen? You see here, these are the blue molecules which are of fresh gas flow, and these pink molecules are the vapor molecules. Since the gas is compressed here, you can see this is fresh gas flow. Now it is completely saturated with the vapor molecule. Once the pressure is released, patient expires or the pressure is released, what will happen? These molecules, which are fully saturated, either will come here to the outlet but they also go inside the bypass chamber through the inlet. Why? Because the resistance of the bypass chamber is lesser. So they have two escape route. Partly they come here and partly they go inside the bypass chamber. So what will happen? Initially, the bypass chamber was not having any saturated molecules. Now it also have saturated molecules. So it will sum up to provide higher concentration of the vaporizer, vaporizing agent to the patient. I hope it is clear now. Now, what is pressurizing effect? It occurs when there are high flow rates, low dial setting, and higher pressure fluctuation. A lower concentration than indicated on the dial is delivered. What was happening in pumping effect? Higher concentration was delivered. However, in pressurizing effect, lower concentration will be delivered, and it happens at the high flow rate. What happened in pressurizing effect? The same concept here. High flow rate is coming. A positive pressure is applied here. The gas will get compressed inside the bypass chamber as well inside the vaporizing chamber. You can see so much of blue molecules. These are all fresh gas flow which is coming at high flow rate. They'll get compressed inside. However, the vapor molecule number will not increase because saturated vapor pressure depends on temperature and not on the ambient pressure as we discussed earlier. So what will happen once the pressure is released here? The gas will expand and it will come here to the outlet and it will be saturated with the vapor molecules which are available, and there will be dilution and ultimately lower concentration will be delivered at the outlet. This is known as pressurizing effect. So how can you reduce these back pressure effects? You can make few changes in the vaporizer in the form of decrease the size of vaporizing chamber, increase the size of the bypass chamber, increase overall resistance to the airflow through the vaporizer, or a long spiral tube leading to vaporizing chamber, that is increase the inlet tube, incorporate an expansion chamber or extrude the wicks from the inlet. In the anesthesia machine, what you can do, put a pressure relief valve or a check valve at the outlet of vaporizing chamber, and you can even put a check valve upstream to the junction of the oxygen flush. These all will reduce in the back pressure effects. How they'll reduce the back pressure effect? You can understand if you understand the mechanism of pumping effect. Because somehow you have to reduce the amount of saturated vapor pressure getting inside the bypass chamber. Let's move on to simple vaporizers. These are historical vaporizers. Schimmelbusch mask. Schimmelbusch mask, you can see here, multiple agents can be used through Schimmelbusch mask, and it is used for open drop method. You can see there's a metal cage, there's a metal frame and a cage over it, and there's a hinge. Once you will remove this hinge, and you have to place here the gauze pieces and pour ether over it. Now, what is Ongston mask with Schimmelbusch mask? What happened? A fence was added to the Schimmelbusch mask. Why? It will prevent the air dilution and increase the concentration of ether delivered to the patient. Now coming to Yonkers and Yonkers Guathame mask. This is a Yonkers mask. There is a metal frame with a metal mesh over it. And Yonker Guathame mask, there is almost same except that there is an inlet for oxygen. This is the first mask with inlet for oxygen, and you can see some holes over here. It will provide oxygen to the patient during delivery of inhalational agent. Now this is Bellamy Gardner's bottle. Bellamy Gardner's bottle is used to deliver ether. You can see this is a Schimmelbusch mask with gauze pieces over it, and the anesthetist is delivering ether through the Bellamy Gardner's bottle. Now this is an important vaporizer for exam, Epstein Macintosh Oxford vaporizer, which was invented in 1952. External appearance, if you will see, you can describe it. There's a handle, there's a lever over here. This one is the lever. These are the temperature compensator. This is a plug or lever. It has to be removed to fill the inhalational agent into it. You can see this is a site indicator to see the vaporizing agent. This is the outlet, and behind it there is an inlet. So there is an agent indicator, temperature compensator, lever, handle, inlet, outlet. It is made up of either aluminum or steel, and it is transportable, but it is however heavy, around 10 kg. So now we'll describe the vaporizer in the same 6 points we have discussed during classification. This is a concentration calibrated vaporizer, mostly used for ether, 0 to 20% calibrated. It is a variable bypass and flow over type of vaporizer. Temperature compensated with ether of freon metal filled bellows, which are here, and temperature stabilized with a water jacket. You can see this is a water jacket around the vaporizing chamber. This is a vaporizing chamber, and this is a bypass chamber. It is a drawer type of vaporizer which is used within the circuit, and multiple agents can be used inside this vaporizer. Now coming to Oxford miniature vaporizer. Similar, in the similar way, we'll say it's a variable bypass vaporizer, which is flow over type with metal mesh wicks here. And it has a heat sink which contains 30% of glycol to provide a thermal mass. It is a drawer type of vaporizer with low resistance and can be used within the circuit as an inhaler. It is not agent specific and not temperature compensated. It is a lightweight vaporizer with a capacity of around 50 ml. Originally, it was produced to be used together with EMO in order to speed the induction of anesthesia. Now coming to copper kettle. Copper kettle was invented by Lucien Morris in 1952. It is a measured flow type of vaporizer. It is a pioneer of measured flow type of vaporizers. And the method of vaporization is also different, bubble through. It is temperature compensated by supplied heat and manual flow alteration. So it was cumbersome for anesthetists because temperature compensation has to be done by manual flow alteration also. It is used out of system since it is a plenum type of vaporizer, and multiple agents can be used. It is available in two models with the capacity of 160 ml and 400 ml. Now this is boil separators. You can see this is an ether bottle. There's a plunger over here. This is corkscrew. You can see a metal string, a cowl, and a glass bottle with a capacity of 300 cc. You can see here lever, off position, graduation mark 1, 2, 3, and on position. So similarly, we'll describe it as a variable bypass vaporizer. It can be flow over or bubble through. There's no temperature compensation. Multiple agents like ether, halothane, trilene can be used. It is a high resistance vaporizer, plenum type of vaporizer. Thus, it is used out of system. And why flow over and bubble through? Once this plunger is not fully depressed, it acts as flow over. And if it is fully depressed, you can see a cow, the gas passes and reaches inside the vaporizing liquid, and then the method of vaporization changes to bubble through type. Now coming to Goldman type of vaporizer. Externally, you can see there is a glass bottle of 30 cc. There's a screw beneath. You have to unscrew it and remove the bottle to fill it. This is inlet and outlet. There's a graduation mark over here on 1, 2, 3, and these are the lever which are moved to change the vaporization concentration output. Similarly, it is a variable bypass vaporizer, flow over with or without wicks. There is no temperature compensation. Multiple agents like halothane and trilene can be used. It offers low resistance and it can be used both in or out of the circuit. And it is a drawer type of vaporizer. Now coming to precision vaporizers. What are precision vaporizers? They provide precise volume percentage of the vaporizer concentration. Coming to tech vaporizer, let's start with tech vaporizer. This is Tech 1 type of vaporizer. It was introduced by Cyprian Company in 1956 as Flowtech 1, used for halothane. However, it was short-lived. Then comes Tech 2 vaporizer, Tech 3, Tech 4, and Tech 5 type of vaporizer. Gradually, there was improvement, and we will going to discuss these four types of vaporizer 2, 3, 4, and 5 in a tabular form to understand the differences clearly. Whenever you describe the tech vaporizer in similar way. Method of regulating output concentration, they are concentration calibrated variable bypass type of vaporizer. Flow over method of vaporization. Temperature compensation is bimetallic strip made up of nickel or copper. That is automatic thermocompensation is there. They are agent specific and they offer high resistance. They are plenum type of vaporizer. Thus, they will be used only outside the circuit. Now coming to the differences. Type of vaporizer we have already discussed. They are concentration calibrated and variable bypass vaporizer. Tech 3 had two bypass chamber and a small vaporizing chamber. And what happened in Tech 4? A control dial has a release button on the left. I'll show you. You can see this is a control dial with a release button on the left. And in the Tech 5, it is a control dial with a release button at the back. So method of vaporization flow over with wicks. However, Tech 5 had spiral wicks. Thermocompensation same, bimetallic strip is used in all except that in Tech 2, the bimetallic strip was inside the vaporizing chamber. In others, it was outside the vaporizing chamber. And in Tech 5, it was though outside the vaporizing chamber. However, it is located at the base of the vaporizing chamber. Sorry, base of the bypass chamber. Now about back pressure. Pressurizing valve was installed in Tech 2, yet it was prone for the back pressure effects. In what they did in Tech 3 vaporizer, two bypass chamber, a small vaporizing chamber was used with a long inlet with expansion, and wicks were excluded from the vaporizing chamber near the inlet to reduce the pressurizing of back pressure effect. Sorry, to reduce the back pressure effect basically, which will include both pumping and pressurizing effect. In Tech 4, the fluctuation back pressure can increase the concentration. And in Tech 5, you will be surprised that though they have used IPPB assembly to reduce the back pressure effect, yet it has more pumping effect than Tech 4 vaporizer, Tech 5. Now, what about tipping to 180 degree? What is tipping? If you will turn a vaporizer to 180 degree, they have standardized it to calculate the concentration output. Of course, tipping was there in Tech 2, and in Tech 3, it was increased up to the 12%. There was increase in vaporizing output up to the 12%. However, there was no effect of tipping till 180 degree in Tech 4, and similarly, no effect in Tech 5. They use baffle system to reduce this effect. From Tech 5 onwards, a locking lever at the rear end was connected to the control dial. This was the new thing which was added from Tech 4 onward. And filling devices, they were all funnel filled initially. From Tech 4, key filling device came into the picture, and further changes were done in filling devices. We'll discuss later on. Now you can see the cut section of Tech 5 vaporizer. See, this is the inlet. This is a bypass chamber. As we discussed, there is a bimetallic strip at the base of the bypass chamber. Now they are reaching the common gas outlet. This is the vaporizing chamber. This is the inlet leading to vaporizing chamber. Here we go. This is IPPV assembly, and we are entering the vaporizing chamber. Flow over type of vaporization occur. There are spiral wicks. The gas is then coming out, and getting mixed with the fresh gas flow and leaves the vaporizer. Initially, it was system of filling device was funnel fill. See, there's a funnel and vaporizing agent is poured inside the vaporizing chamber. There was overspilling and it was not very accurate method. Then comes the key field. Key field is just like a lock and key type of system. You can see this is a vaporizer inlet which is a hole over here, and the corresponding groove is found on the filler tube. To be more clear, this is a bottle. You can see a bottle collar with different ridges of different dimensions, and similar grooves will be seen on the filler tube, which can be fit over the bottle. And here what will happen, this is a vaporizer inlet. You will just put that filler tube inside here, just like this. To lock it, you have to pull this lever down, and once it is down, raise the bottle upwards, pull this lever, and the vaporizing agent will start flowing inside the vaporizing chamber, and you can see it through the side tube. Now coming to modern vaporizer. Tech 7 vaporizer. Tech 7 vaporizer essentially the same as Tech 5 vaporizer. There was no spill system, and it was actually aesthetically improved. And what further improvement was there? We have already seen funnel field, key field. Here quick fill was introduced, which was for sevoflurane, and easy fill system, which is for specific for other vaporizers except desflurane. You can see easy fill system. This is a bottle cap. It has grooves over here, which will fit in the corresponding ridges of the bottle. Here it will fit, and then you can just push this bottle on the vaporizer inlet or filling port, and it is very simple and easy to fill without getting any misfilling, and even over spilling was reduced with this easy fill system. Now coming to Tech 6 vaporizer, that is for specifically for desflurane. It is measured flow type of vaporizer, which is the previous vaporizer we learned, which has measured flow was copper kettle. It is a measured flow type of vaporizer. The method of vaporization here is different injection. It is gas vapor blender type of vaporizer, which is electrically heated. You can see there's a cord here, and it is externally heated. Agent specific for desflurane, a plenum type of vaporizer which offer high resistance. Thus, it can be used only outside the circuit. The concentration dial is calibrated from 1 to 18%. This is a concentration dial. It is calibrated from 1 to 18%. You can see 10. Here it is 10 in bolder font. Why? The graduation is 1% till the 10 and 2% from 10 to 18%. There's a filler port in the front. Now there should be a question, why there is need for specific vaporizer for desflurane? Why it can't be the same like any other inhalational agent? So let's learn about it. Desflurane, it has high saturated vapor pressure around 669 millimeter of mercury at 20 degrees centigrade, and it has low boiling point of 23.5 degrees centigrade, even less than the room temperature. So to compensate for such high saturated vapor pressure, a high fresh gas flow are required to dilute it, which will not be economically feasible. And at room temperature, it will intermittently boil. Then what will happen? It will result in excessive agent delivery. And as we have already understand the concept, due to large loss of latent heat of vaporization, it will then cool faster, resulting in exponential decrease in saturated vapor pressure and under delivery of the agent. So that is why we need a separate specific vaporizer for desflurane. Now try to understand what happens inside this vaporizer. This is a liquid sum which contains desflurane. It is electrically heated at 39 degrees centigrade, and the saturated vapor pressure here of desflurane reaches to around 1500, that is approximately 2 atmospheric pressure. If you will deliver this pressure, it will be very fatal. So what happened? There is a differential pressure transducer valve over here. What happens when the fresh gas flow enters here? There's a fixed orifice, and there will be a pressure difference generated, which will be transmitted to the differential pressure transducer, and this will convey a message to R1, resistor 1, and it will ultimately reduce the pressure according to the information given by this differential pressure transducer. And here the pressure of the desflurane will reduce. then it will flow further, and this is R2, which is controlled by the control dial. And further the pressure will reduce, and what will happen, both the desflurane and fresh gas flow will come at the same pressure and will get mixed over here, and a desired concentration, which is shown on the control dial as volume percentage, will be delivered to the patient. Now coming to selector tech system. What is this selector tech system? This is specifically for tech vaporizer to prevent the inadvertent simultaneous delivery of the two inhalational agent, and also to prevent contamination between the vaporizer. You can see there's a rear protrusion on the vaporizer, and in these rear protrusion at the back side there will be holes which will be correspond to these protrusion and will fit into these protrusion. This is a selector tech bar. So the vaporizer will with hole will sit on this protrusion and will be locked here. You can see here these are the protrusions on the selector tech bar, and there is a hole on the rear protrusion of the tech vaporizer. You can also see this is a lateral rod. What will happen once you will switch on the dial, this lateral rod will move more laterally, and it will block the adjacent vaporizer, so that the adjacent vaporizer cannot be opened until and unless this one is closed, or I mean this one is closed, then only the adjacent vaporizer can be opened. Now coming to Traeger vapor. These are concentration calibrated variable bypass type of vaporizer. Method of vaporization is flow over with wicks, and these are temperature compensated with metal rods, are agent specific, and plenum type of vaporizer can be used only outside the circuit. So externally you can see there's a zero button or O button here, which has to be uh, compressed on the control dial to just turn the vaporizer on. And here you can also see a T. This is for transportation. Why for transportation? So that there should be no tipping. And thus these two isosceles triangles should correspond to each other while transportation. Okay. And this is calibrated from 0.2% to 0.2 to 15 liter per minute. This is a site indicator, and these are the filler port. So just like we learned, there's a selector tech interlock mechanism in tech vaporizer. Here also there are two interlock mechanisms. You can see here there are protrusion along with the pin. The same at the rear end of the vaporizer, there will be holes and apertures to accommodate these pin as well as this protrusion. And you can see there is a lock at the control dial also. This is a lock, and there's one more lock here. Once you have mounted the vaporizer on the bar, you have to open this control dial lock, and before opening this vaporizer, you have to shift the lever to the adjacent side of the vaporizer to lock the adjacent vaporizer. Once this is done, then only you will be able to open the vaporizer which you want to use. So it has two interlock mechanisms. Now there are three different filling systems here. Simple filling, key filling, we have already discussed, and sevoflurane vaporizer have quick fill system. You can see here, this is specifically for sevoflurane. Now coming to devapor, here also devapor is used only for desflurane. There's on, off, and T mark over it, and 1 to 18% of graduations or calibrations are there to deliver concentration higher than 12%. You will see that on the dial, more than 12% graduations are then shown in the inverted order. The agent level indicator is in front on the right side. And you can see here, there are few markings over here. It will be operational, then it will become green. No output, then it will become red. There's a warm up time and fill up. If fill up is required, then this will blink. And whether the vaporizer is battery or powered or running on the outside heat, it will be indicated here. There's a word of caution. The D vapor is not designed to be used at an angle of more than 10 degrees. Why? Because at the greater angle, an uncontrolled concentration of vapor may result. Now, D vapor filling system, there's a different safety fill system for this desflurane vaporizer. The difference is that even while the vaporizer is functioning, you can fill the vaporizer with safety fill system. Now coming to Aladdin cassettes, this seems quite sophisticated, different type of vaporizers. However, they are functionally similar to conventional vaporizer. How? Because they are concentration calibrated, variable bypass type of vaporizer, which uses method of vaporization as flow over, and they are automatic thermocompensated by electronic method. And it is used with Detex Angstrom machine AS318. The vaporizer has two control parts, one electronic control mechanism, which is in the anesthesia machine, and portable cassettes with handle, which are inserted into the slot in the anesthesia machine. There is no effect of tipping, and remember that it cannot deliver the volatile agent in absence of main power, battery backup, or adequate oxygen pressure. This Aladdin vaporizer can be used for all inhalational agent, including desflurane. The cassette are key fillers or easy fill system. Sevoflurane used either key filled or quick fill system. The capacity of cassette is around 250 ml when full. Now coming to Draeger Diva type of vaporizer. These are measured flow vaporizer and the method of vaporization is injection type. It can be used for all modern inhalational agents including desflurane. The Draeger Diva is a part of Draeger GS anesthesia workstation. Now coming to McQuet 950 series injection vaporizer. These are also measured flow type of vaporizer which use method of vaporization injection and can be used for all modern inhalational agents including desflurane. McQuet flow eye anesthesia is McQuet vaporizer is used with the McQuet flow eye anesthesia delivery system. Now, what are the safety features for the vaporizer? There are key fillers which prevent filling the vaporizer with the wrong agent. There are low filling port which will minimize overfilling of the vaporizer. Secured vaporizer minimize movement and thereby minimize tipping. There are interlock system as we learned. There is selector tech system in the tech vaporizer and two interlock system in the Draeger vaporizer to prevent administration of more than one inhalational agent simultaneously. Concentration dial increases input in all when rotated counterclockwise. Before concluding, we should all know what is Rath and Eisencraft formula. How to calculate how much ml of liquid will be used per hour. There's an approximate working figure that is 1 ml of liquid anesthetic on vaporization produce 200 ml of its vapor. This is the thing, approximate working figure which we use with the formula for ml of liquid used per hour. The formula is set percentage into fresh gas flow which is set and 3. Here set percentage is volume percentage. However, use 3.3 for sevoflurane. For example, if 2% is set for isoflurane for the fresh gas flow of 6 liter per minute, then you will calculate 2 into 6 into 3, that is equal to 20 ml of liquid will be utilized in 1 hour. Thank you so much for your patience listening. I hope I have made clear that what are vaporizer and their details. Now we are open to questions. Thanks a lot.